Okay, so let's look at number 21 here from the example packet. So in this one, the water wheel is rotating 6 revolutions a minute. And the point P, point P starts right here. And then 2 seconds later, it's here. So it hits its peak 2 seconds after it starts. And then it takes, it goes 6 revolutions a minute, so that means 1 revolution every 10 seconds. So it's doing 1 rev every 10 seconds, which means the period is going to be 10 seconds. Okay, which also means that when we come up with an equation for this thing, normally a period for spinning around a circle is going to be 2 pi, but the period is going to be related, or B is going to be related because it's 2 pi over 10. So that will be pi over 5 for our B that we'll put in the equation. Another thing that I want to do here is this. Let me first stretch out here. Well, we got to figure out what's going on. At time 0, the person's at P. Or not the person, the point is at P. So if I actually start an axis right here, this is where the water hits. So I'm just going to come across like this, because that's kind of like ground level or sea level. And then as time goes on, here's time. Let's assume that the wheel is spinning this way. So at first this point is going to get higher, then it's going to get lower, and it's actually going to go underwater for a little bit. Then it's going to come back up, and it's going to go back down again. And so this is a graph of what's going to happen to this curve, to that point over time. And remember, the peak here is when t equals 2. And it will make 1 full cycle every 10 seconds, so it'll hit the peak again at t equals 12. Which means the low point here is t equals whatever the average of that is, 7. Okay, so we also know that the midline right here is y equals 6, and the low point's at -1, and the high point is 6 plus 7 more, so the high point's 13, low point, low point -1. All right, so we've got the period, and we've got our B. The amplitude of this thing is how much it got stretched up and stretched down. So it's stretched up and stretched down by 7. So amplitude A is going to be 7, which is the same as vertical shift, or vertical stretch. The vertical shift, that's going to be our K. Well, the center isn't at 0, 0. The center, the way that I did it, is up 6 units. So this is going to be 6 units up. And the horizontal shift, I think the easiest graph to go for here would be the cosine graph. And that's just cosine shifted 2 units over. So it's 2 units to the right to get what we're looking for. So if we came for cosine. So if we came up with an equation for this, the equation would be y equals 7 cosine parentheses pi over 5 x minus 2 plus 6. So that's A. That's probably the simplest way to come up with the equation that I can think of. The next one is what time does P first emerge from the water? So P's going around this circle. It goes into the water here, and then it emerges from the water there. So on the graph, that's P goes up, comes down, goes into the water, then comes out of the water here. So we're looking for this value. Now you can get that by graphing the thing and finding the 0 on your graph, and that's okay. But what I'm going to do is I'm actually going to work it out where I show you the algebra that goes into not just solving for this one, but actually solving for all of them, and then how to calculate this one directly. So we know that this happens when the height is 0, not below water and negative, but at 0. So I'm going to set y equal to 0 here. and then solve this equation. Now, instead of that full long thing, pi over 5x minus 2, I'm going to call it theta for now, just to make life a little bit simpler in the calculations. So now when I isolate, I got negative 6 over 7 equals cos theta, and then I can do cos inverse of negative 6 over 7. And if I do that, I get, and I'm working in radians here, what did I get? I got 2.6 radians. Well, remember also, though, that's just one answer that works. So if 2.6 radians works, so does 2 pi minus 2.6 radians, which is the same thing as negative 2.6 radians also works. And remember, it's not just those two answers. It's those answers plus 2 pi k and plus 2 pi k, where k is an integer. So you got to remember that you get all those different answers too. Okay, so I've got that now. All right. So these are our thetas that work. But remember, theta doesn't exist in our problem. Theta is really this. So I need to replace what I have now. So I've got one set of thetas that's 2.6 plus 2 pi k. And I've got another set of thetas that's negative 2.6 plus 2 pi k. So then what I need to do is switch out the theta for my pi over 5 x minus 2. And I'll do it over here too. And so now what I'm going to do is multiply the 5, divide the pi, and add the 2. So if I just multiply both sides by 5 over pi, then this turns into, let's see, 13 over pi plus, and then I got to multiply this one also by 5 over pi. So that comes out to 10k. And then this will turn into something similar. It'll just be negative 13 over pi plus 10k. Then I got to add 2 to both of them. So this is going to be x equals negative 13 over pi plus 2. Or, sorry, 13 over pi plus 2 plus 10k. And this one will turn into negative 13 over pi plus 2 plus 10k. Okay. So if you just plug in different k's as you go through here, you'll find different places where the x-axis, where y is 0, you'll get different x values. So like, for example, when you plug in k equals 1, so if k equals 1, let's see, or actually, let's start with k equals 0. So if k is 0, we get 13 over pi plus 2. So we get an x equals 6.138. And then over here we get x equals negative 13 over pi plus 2, which is negative 2.138. Well, this isn't going to really help us because that's negative time and we started a stopwatch, so that's not going to help. This one, where's that on the graph? That's going to be right here. So k equals 0 didn't get us far enough, but we could do k equals 1, and that would get us far enough. In fact, k equals 1 would be good to put into here, because then I'm going to subtract something from it. So negative 13 over pi plus 10 times 1 is going to be, oh, I forgot the plus 2. So that's going to be x equals, when k is 1, x equals 7.862. And this is this point right here, 7.862. Remember I said this point over here, what did I say that was? 6.138. If you took the difference from here to 7, you should get the same difference as if you went from 7 to 7.862. They're both 0.862 away from that middle of 7. Okay, so anyway, that means that our final answer here is at 7.862 seconds. All right, I hope that helps.